Hi guys, so in today's video we're going to be looking at the atmosphere. Just a quick disclaimer, I did write the first topic in like a grayish color, so I'm not really sure if you're going to be able to see it, but I am going to read what I wrote on the paper anyway, so it shouldn't be a problem. Okay, so we're going to be looking at the atmosphere, but first, what is the atmosphere? The atmosphere is the mixture of gases held around the Earth by gravity. The mixture of gases consists of 78% of nitrogen, 21% of oxygen, less than 1% of carbon dioxide, and the other gases, including water vapor, is 1%. And then we're going to also be looking at density within the atmosphere, and density refers to how many particles are present in a specific volume of gas. So, the density of gas particles decreases as the distance from the Earth increases. So, for example, for you to understand how density works, you know how if you go higher up, like let's say you're traveling up a mountain, people would say the air is thin. That is the density in the air. So, that is basically what density refers to. That's an easier way to understand it. Okay? Then the atmosphere has 4 layers, which is the troposphere, stratosphere, mesosphere, and the thermosphere, and each layer of the atmosphere has a different temperature gradient. In other words, each sphere has its own temperature. None of them are the same. Okay, so now we're at the troposphere. So this layer extends from the sea level to about 10 kilometers above the surface of the Earth. You have done sea level, I think, in geography, so that shouldn't be a problem. It contains more than 70% of the mass of the atmosphere, and it has the greatest density. The temperature decreases as the distance from the surface increases. So like, for example, if you're taking an airplane ride, obviously it's going to be much, much, much colder compared to you being on the ground. So that's again what temperature gradient is. It's different temperatures within the spheres. And then weather occurs in this layer. Another thing is, like I said, the mountain areas. This is where the mountains are. Again, the airplanes fly in the troposphere. So that is what happens in the troposphere. It is the lowest level in the atmosphere. Okay, next we have our stratosphere, which is above the troposphere. So this layer extends from about 10 kilometers to about 50 kilometers above the Earth's surface. The air in the stratosphere is very thin compared to the air in the troposphere, so there's a very great chance you will not be able to breathe there. If you're struggling to breathe like on a mountain top, yeah, going to the stratosphere is just going to make things worse. So airplanes fly as high as the stratosphere, so that is how that's the limit that they have to fly, because obviously if you go higher than that, we're going into another part of the atmosphere. So that is as high as airplanes can fly. And it includes a band of ozone gas, which absorbs ultraviolet radiation from the sun. I'm not sure if you guys have heard of people saying, oh, there's a hole in the ozone layer and all of that. That is what they're talking about, the ozone gases. So you can quickly look that up if you don't understand what ozone gases are, but that's just to refresh your memory on what ozone is and ozone gases are. So the absorption of UV radiation increases the temperature of the stratosphere. As a result, the further away from the Earth, the warmer the air becomes. So we saw in the first part of the atmosphere, it is where the weather occurs. So obviously it's going to be a bit warmer, and then the stratosphere is going to get colder because we're moving away from the ground. But here it says that it's going to be a bit warmer because of the UV radiation. UV radiation is very, very bad. It can cause cancer, if I'm not mistaken. So obviously that radiation causes this area in the atmosphere to get hotter or to have a warmer temperature compared to the other areas in the atmosphere. So too much radiation interferes with life on Earth. Like I've said, it can damage plant life, it can cause cancer. It is really, really bad. So thank goodness for the stratosphere. Additionally, weather balloons also fly as high as this. So if you ever, I'm not sure where you can go and see weather balloons, but I remember in America, there was like a weather balloon incident. So that's as high as they can fly. Okay, next we have the Mesosphere. So just a way to remember the mesosphere, think of meteors. Mesosphere, meteors. So that's a great way to remember it. So this layer extends from about 50 to 80 kilometers above the Earth's surface. The air is extremely thin and very cold. This is still enough air in the layer to burn up small rocks and dust entering from space. So, you know when you see a shooting star, those are like meteors. That is where they burn up, is in the mesosphere. So, yeah. I think that's all I can say about the mesosphere. Then burning rocks are visible from the Earth and known as shooting stars. Okay, I've already said that. So this is where you'd normally see your shooting stars. Okay, last we have our thermosphere. This layer starts above 80 kilometers from the Earth. The International Space Station, otherwise known as the ISS, orbits the Earth at a height above 370 kilometers. I'm going to attach a picture of what the ISS looks like. It is so cool. And I'm not just geeking out because I love science, but it's really, really cool. Then the lowest part of the thermosphere absorbs UV radiation and dangerous X-rays from the sun. Like we said, what happens here in the stratosphere, it also happens here, but more intense. Why? Because it is closer to the sun. It is closer to, this is not scientifically, but outer space. Okay? And it reflects radio waves back to Earth for TV and radio broadcasts. So this is where all your satellites are. I'm going to also attach images of satellites so you can see what they look like, not just the ISS. So that is what happens in our planet's atmosphere. I hope this video is very helpful. Yeah, bye.